Welcome to Brain Vision.
In this problem, we have a ball that is fired from a tube with a given velocity. We know its coefficient of restitution when it hits the ground. We want to determine the maximum height after it strikes the ground and bounces off the surface. So, firstly, we will use kinematics and consider the vertical motion from A to B. So we'll take the upward direction as positive, and we'll use the kinematical equation that the y component of v at b, vb y squared, must equal to va y squared plus 2 times the acceleration in the y direction into the position at b minus the y component of the position at a. So this simplifies to 6 sine 30 degrees for the y component of a's velocity, or the velocity at a, all squared, plus 2 times the acceleration in the y direction is due to gravity, so that's minus 9.81 meters per square second, and the change in position is minus 2 minus 0. And so we get vby, if we take the square root of all this, to be 6.9455 meters per second, and this is negative, so this is downwards. So that was kinematics. Now we'll look at the coefficient of restitution. So the y component of the rebounding velocity at b, we'll call it v prime by, and the ground does not move, remember. So again, if we take the upward direction as positive, the coefficient of restitution E is equal to the velocity of the ground after the collision minus the rebound velocity of the ball v prime b in the y direction over the initial velocities of the ball in the y direction before it strikes the ground minus the initial velocity of the ground. So the coefficient of restitution is given as 0.8. And this is equal to 0 since the ground does not move, minus v prime by over minus 6.9455, which we just calculated, minus 0. And so if we rearrange this, we can find the velocity of the ball after it has rebounded in the y direction is equal to positive 5.5564 meters per second, and that's upward. So now we have the y component of the ball after it rebounds off the ground, and we can go back to kinematics and find the maximum height h that the ball will obtain. So again, we'll consider the vertical motion, and we'll take the upward direction as positive. And remember that at the maximum height h, vc in the y direction is equal to 0. So we use the equation vcy squared is equal to the velocity after the rebound v prime b y squared plus 2a into scy minus sby. So using this equation, remembering that Vc in the y direction is 0 at the maximum height, the initial component of the y velocity is 5.5564, and that's squared, plus 2 times the acceleration, which is simply due to gravity, minus 9.81 meters per square second, into h minus 0. So from here, we can rearrange this equation and find the maximum height h the ball will reach after it has rebounded off the surface is 1.57 meters.